Hello and good morning, CTS265 Section 840 students for the fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and today's video tutorial is going to be on OSPF route summarization. And we've got a Cisco Learning Labs discovery activity here. It's discovery activity number 12. And again, a great activity to reinforce how route summarization works in OSPF, as well as some of the limitations that we're going to have when we go to do that route summarization. Now, this should seem very familiar with respect to the concept of doing route summarization based off of our work already with EIGRP. And so let's go ahead and dig in here. You can see we've got the diagram on the right, so it wants us to investigate the routing on router 1. So it drops us already into privilege exec, and I'll say show IP route OSPF. And as you can see, we've got quite a few routes in the routing table. And from just taking a look at the blocks of routes, we've got 192.168.20 to 23. And then we've got this very nice symmetrical, or I should say linear, layout here from 32 to 39, kind of hinting that maybe we're going to be able to get away with a single summary for all of these, and then possibly a single summary that is just for all of those guys there, right? Okay, so again, we're learning about these from Ethernet through Ethernet 01, and these are through Ethernet 02. Excuse me. So let's see what it's asking us to do. It wants us to take a look at the database next here. So what we would want to do is say show IP OSPF database. Now remember that these are being seen as intra-area routes, even though they're being learned out the Ethernet 01 and 02 interfaces. Why does router 1 see these as intra-area routes? Because router 1 is in area 0. Why are they not being seen as type 3s, as summary LSAs? And you've got it, because router 1 has interfaces in each of these areas, right? Now, if I were to go to router 4, and we'll jump on router 4 here in a second, is router 4 going to see everything as an intra-area route, or is he going to see it as an inter-area route? And we know that router 4 has an interface in area 0, and the loopback is probably in area 0 as well. However, router 4 does not have interfaces in area 1 and area 2, so he will see them as inter-area routes. Remember, router 1 is the ABR, and by definition, the ABR must have at least one interface in area 0 and at least one interface in any non-area 0 area. And so does this guy meet the requirement? Router 1, he certainly does. Here's his interface in area 0, and he actually has two interfaces in non-area 0 areas. So he definitely qualifies as an ABR, right? And then you can see here, these are the large chunks of loopback, I'm assuming these have got to be loopback addresses that we're seeing here in the routing table. So let's go ahead and clear the screen, and I'll come over to router 4. Let's jump on router 4, and if I do a show IP route OSPF, what does router 4 see? Again, just like we thought, he sees all of these as type 3 LSAs. Now, here's the problem when we look at the routing tables on router 4 and router 1. If I say I'm sorry, not the routing table, the OSPF database, the link state database, when I say show IP OSPF database, when we look at the link state advertisements, what do we see? Well, we're seeing that we have a type 3. Remember, you're going to get a type 3 LSA for every network that is being learned. And so who's my advertising router? Well, it's router 1. That's the router ID for router 1. And what is the link state identifier for the summary type 3 netlinks, the type 3 summary LSA, right? The link state ID is the network ID, right? Or the network number for that route. And so you can see here that we're going to end up with a whole bunch of route, or I should say LSA entries here in the link state database. So we probably want to trim this down a little bit and optimize, oops, sorry about that. We want to optimize the way that OSPF is going to be running here in the link state database size. So we just took a look at that. So what we want to do is we want to summarize, right? Now remember, where did we say that we have to do the summarization in OSPF? Unlike EIGRP, which is a distance vector protocol, EIGRP says you can summarize anywhere you want, right? Anywhere, at any time, for any reason, we can summarize an EIGRP on any interface. With OSPF, it's very different. You can only summarize at an ABR for routes in the domain or at an ASBR for your external routing information, right? So let's go ahead on router 1 and let's make this happen. So we're going to go into global config. We're going to say router OSPF 1, and I'm going to create 2 summaries. The first one is going to be for area 0. I'm sorry, for area 1, and then the second will be for area 2. So we're going to say area 1 range, and this is the range that we had above where we had the 192.168.20.0, and we're going to put this in as 252.0. So it's going to be a /22. And again, it's always a good idea to take a look at the ranges that you're dealing with, right, and to work it out by hand really quick. So here's the, oops, sorry, there's the interesting octet. So we've got 20, 21, 22, and 23, and that definitely looks like 13. 23. And so what are these values in binary? So 0, 0, 32, 16, 8, 4, 0, 0. So 1, 2, 3, 4, 1, 2, 3, 4. And so then from there we would go to 21, 0, 1. 22 is going to be 1, 0, 1, 1, 0. And 23 is 0, 0, 0, 1, 0, 1, 1, 1. Let me make sure I've got that right. So 16, 8. Oh, wait a second. 16. Yeah, 8, 4 is 20, 22, 23. So we're good there. So when we take a look, where do they no longer match? Well, they no longer match right there, right? That's where they stop matching. So we've already got 16 bits that match, plus the 17, 18, 19, 20, 21, 22. So, well, actually, plus 6 is what I'm saying there, is 22. So we know we've got a /22. We know that that is a 255.255.252.0. And you should be able to do it that fast if you're called upon to do any kind of summarization in the exam format. So make sure that you have this down cold, like second nature, and that you can figure it out very quickly. All right, and does it match? It certainly does. Now, if we take a look at this next set, this 32 to 39, right? That is a whole very large range of addresses. Now, these are all /24. So how could I see what the subnet is on those? Let's put in the area range statement here. Let's finish this up for area 1. And again, remember, take a look at the summarization. Do we do it on an interface like with EIGRP? We don't. We do it on the ABR. We do it under the router OSPF global config section, and we're doing it by area, right? So, because again, the link state database needs to be the same on all of the routers in an area, right? And then we need to make sure that that information is synced up. And so that's why we do it on the ABR, is to control where the summarization gets done. Because what we can't do is we can't just simply say, oh, well, I'm going to go do a summary on this interface and in the middle of an area in the hopes that that is going to be picked up. It's the same thing when you're doing route filtering, which we're going to be getting into here in a couple weeks. Is when you're doing your filtering, it's the same thing. You're going to be doing it at the ABR. You're not going to be filtering routes in the middle of an area, right? Okay, so we've taken care of the first summary. Let's come over to router 4, and now let's run this command again here. And what do we see? We see that we now have an inter-area summary for the 192.168.20.0/22. Now, I still have this huge run of addresses here, right? 32 through 39 that we need to deal with. However, I have shrunk down the routing table. What about the OSPF database? So show IP OSPF database. Absolutely. We have a single entry here. So my question earlier was, how can I tell what the subnet mask is of that type 3 LSA that we're learning, which is a summary? I would simply say show IP OSPF database summary for 192.168.20.0, and there we go. And so I'm actually displaying only the type 3 LSA and only for that link state ID, right? And so here it is right here. Who's my advertising router? Well, we know it's router 1. Here is the link state ID, which is the summary network number. And what is my net mask? The network mask is a /22. What's my metric? It's 11. So remember, it's probably 10 for the first hop and then +1 to get to a loop back. And that's where we're coming up with this 11 is the metric. So again, this is how I could see what the network mask is, right? Okay, now the key, and again, we may not get too much into this here in the course, but this is definitely important, is that that routing bit is set. If the routing bit is not set, and what you would see is there would be nothing here. It wouldn't say routing bit not set. The routing bit is just not going to, it's not going to say anything here. If the routing bit is not set, you will not see this route in the routing table, right? So routing bit set is very important. Okay. So let's go ahead now, and we're going to implement the second summary, which was not a 250, and that pulled that back up by accident there. So we're going to say the next area range is going to be this 192.168.32.0. Apologize there. And we're going to do 255.248.0. And so again, you should be able to come up here quickly and at this pace, oops, where are we at here? And at this pace, take 32 down to 39. So we would say for 32, it would be 0, 0, 1, 0, 1, 2, 3, 4. And then it's pretty easy from here, right? So we've got 32, 33, 32, and then what are we doing? 34. So there's 34, and then 35 is going to be that, and then 36 is going to be, so 32, whoops, pull that back, 32, and the 4 is going to be 36, and then 0, 0, and then 37, whoops, 37 is going to be 36, 37, and then 38 would be 0, 0, 36, 37, 38. And then 39, finally, is going to be 32. And 4 is 36, 37, 38, 39. So where do they no longer match? Right there is where they stop matching. And keep in mind, we've got this value that's on here. Okay, so when we go to put the summary in, we're going to have a value, right, of 32. So we've got 1, 2, 3, 4, 5. So if we had 16 bits already matching plus 5, we know that's going to be a /21. So we know a /21 is 255.255, and then the first 5 bits, which would be the 128, the 64, the 32, and the 16, and the 8. We add these up, you get 192, 224, 240, 248.0. Right? So there's my summary. Again, it's always great exercise to go through and work those summarizations out manually. Okay, so we added that summary in on router 1. Let's now step over here to router 4, and let's see what router 4 shows now for the OSPF database. And actually, he's still showing the same. Oh, you know why? Do you see the mistake I made? You got it, the area number. So let's pull this out because that is not even a valid area for that range, and then let's pull it back, and we're going to say area 2. There we go. All right, so we'll take a look at router 4 now, and what I would expect to see with router 4 is that we've got a much smaller database, and we do not... Did I typo something? Let me check. I must have typoed 255.255.248.0, 192.168, area 2 range, and that should have been correct. Let's check it out again here. Let's make sure. There we go. That was interesting. Let's go back and take a look at that. That was interesting. So take a look at what happened, and this may be a bug of some kind. So we have the original area range statement for the first series of networks. I added the second in, and then it left, for whatever reason, it left that statement there, 32.255, and the whole host of other routes that make up that are going to make up that summary. And then down here at the bottom, it looks like it finally it cleaned it up. So now we have the entries that we would expect. So that was interesting. And again, probably just a small bug. All right, so let's go ahead and say show IP Ospf Database for the for the summary 192.168.32.0. So here is my type 3 LSA for my summary. Again, there's the link state ID, which is the summary network number, or the network ID. There is my net mask of a /21, and there is my metric. Now, let's go ahead here and make sure, and we'll take a look at the routing table as well. So if I were to say show IP route, we would expect that we're going to have 2 inter-area summaries, and we do. They are both right here, my /22 and my /21. That was the first one we did for area 1. That's the second one that we did for area 2. And again, you can see it definitely economizes the routing table and the OSPF database in a pretty significant way. And again, depending upon how many routes that you might be summarizing. So we've already taken a look at the link state database. We took a look at the type 3s. Now the final thing that we're going to look at is on router 1, where we're doing the summary. If we look at the routing table on router 1, where we're doing the summary here, what we're going to see is we have 2 summary routes to null 0, right? They show up to null 0. And why is that? Again, remember that null 0 interface is saying, excuse me, that if I'm receiving traffic for a network that is in this summary range, and I don't actually have a network that matches that network, it's going to go to the bit bucket. The traffic will just get dropped. And what this prevents is routing loops and traffic just simply looping through your network. Instead of letting that happen, we send it to null 0, and the traffic gets dumped into the bit bucket, which again is just a term for the traffic being dropped. So now remember, we talked about in our multi-area OSPF setup, we had talked about one of the drawbacks of virtual links is that we are unable to do summarization. So let's try that out here, right? So I'm going to come over to, let's see, router 2, right? So I'm going to come on to router 2, and I'm going to say, we'll go to global config, we're going to say interface loopback 100, and let me make sure, do show IP interface brief, that we don't have a loopback 100. Okay, we don't. So I'm going to say IP address 172.16, and let me double check. Okay, so we're using that for the WAN links. Let's use 10. We'll use 10s. So we'll use the 10 space here. So I'll say 10.10.10.1. We'll say interface loopback 101, and that's going to be IP address 10.10.11.1. And actually, let me go ahead and put these into IP OSPF1 area, and I'll put these in area 100. interface loopback 100, IP OSPF 1, area 100, and we'll do one more. Interface loopback 102 is where we left off. IP address 10.10.12.1, IP OSPF 1, area 100. So now let's say do show IP OSPF interface, and actually want the brief. And I should have 3 interfaces right now. And you can see them right here. I've got 3 interfaces that are in area 100, right? Now, these are running on router 2. So, if I go over here to router 1, and I say, do show IP route OSPF, do I see those 10 dot interfaces? I don't. What if I go over to router 4? Remember, router 4 is way over here on the left-hand side. If I say show IP route OSPF, do I see any 10 dot addresses? I do not. Now remember, the reason that we don't see those 10 dot addresses, and let me go ahead and draw it in here, is I'm kind of adding in, basically doing this on router 2 and saying that this is area 100. So why are the routes not being learned for area 100? You've got it. This is very similar to the lab activity we did. So area 100 has no connectivity and no ABR that it can connect to here into area 0. So therefore, this relationship right here between area 100 and area 1, there is no ABR there right now. So what we're going to do is we're going to go ahead, we're going to stretch via a virtual link. So we're going to stretch via a virtual link here. This is going to be my virtual link 0, right? And we're going to make router 2 appear to be an ABR for area 100. So let's go ahead and do that. Let me clear the screen here, and we'll go back to router. Whoops. We'll actually have to do it on both router 1 and router 2. So the way that we're going to handle this, right? Remember, we're going to create a virtual link. So I'm already in this router OSPF 1. So I'm going to say area, and what is the transit area through which that virtual link is going to go? Area 1. So area 1, virtual link, and then what do I put here? I have to put down the router ID of the virtual link neighbor. So if I come here to router 2 and I say do show IP OSPF, what is my router ID? It is 2.2.2.2. So on router 1, I say area 1 virtual link to 2.2.2.2. And on router 2, I do just the opposite. I say router OSPF 1, and I'm going to say area 1 virtual link, and what is the router ID of router 1? My guess is it's 1.1.1.1. So if we say do show IP OSPF, whoops, sorry about that. That guy's done. So if I were to say do show IP OSPF, you can see that it is 1.1.1.1. Again, we could have guessed that, but it's probably a good thing to check. So 1.1.1.1. Now, these guys have reachability between each other. So we should see, if I were to say, and there we go. We've got the OSPF link has gone from loading to full. So now when I say do show IP OSPF interface, and let's do that brief again, I apologize there. You can see that we have this virtual link 0, which is exactly what we would expect. It's under OSPF process ID 1, and it's area 0, because again, I'm stitching area 0 and extending it from router 1 through area 1 to router 2. Again, I assume the cost of the actual link between the routers, right, for the virtual link cost. And you can see I've got one neighbor. So now, just like in the lab that we did, lab 3-1, if I were to say over here on router 1, now let's say, whoops, sorry about that. On router 1, now let's say do show IP route OSPF. There are my inter-area 10 dot addresses. Again, now remember they're inter-area because router 1 has an interface in area 0, but again, this is like another area. This guy is now pretending to be an ABR. So if he is an ABR for area 100, when those routes hit the ABR, they're flooded as type 3s across that virtual link tunnel that we have, virtual link 0, to router 1. Because remember, router 1 doesn't have an interface into area 100. It has an interface into area 0, which we have extended to router 2 so that area 100 sees router 2 as an ABR. So we are going to get these type 3 LSAs for these 10.10.x.x routes that we have up here. So this leads us to the discussion. Remember, I made the comment that you can't do summarization. However, in the lab, what happened? We went on to the router where we had that area 100, and I basically said, we said area 100 range, and we did a summary for the area 100 range. And so taking a look up here real quick, you can see we've got 10, 11, and 12, so 0, 0, 0, 0, 8, 10, 1, 2, 3, 4, 1, 2, 3, 4, and then 11 is going to be 1, 1, and then 12, whoops, 12 is going to be 1, 2, 3, 4. We got 8, 10, sorry, got to back that up a little bit. Boom, 0, 0. So where are they no longer the same? Well, they're no longer the same right there. So my summary is going to be 1, 2, 3, 4, 5. So 16 plus 5 is going to be 21, and the 8 value bit is on. So the summary would be 10.10.8.0/21. So let's go ahead and drop that summary in here on router 2. So area range, or area 100 range 10.10.8.0, and then a /21 is going to be 255, 255, 248. So the first 5 bits, 192, 224, 240, 248. So it should be a slash, or it should be a 255, 255.248.0. So we'll put that area range in. Let's come all the way over here to router 4 now and say show IP route OSPF. And do we have an inter-area summary? We do. So check that out. But remember, I said we can't. When we're doing virtual links, we can't summarize, right? That ABR is incapable of doing summarization. However, we're talking about the direction of the summary. So if I come back to my diagram here, remember, we're doing a little summarization from over here for area 100. And that summary is coming this way. What if I had a bunch of loopbacks here, and I guess we could add these off of area 4, off of router 4 in area 0, and I'll do some other. Let's see, 192. So I'll do some other 10s. We'll do 10.99.99, and then we'll make up some different. Actually, we'll keep it simple for the summary. So if I come onto router 4, right, and I create some. Do show IP interface brief. Let's see what loopbacks we have. Only loopback 0. So I'm going to say interface loopback 100. We're going to say IP address 10.1.1.1. So we'll keep it simple here. 255, 255.0. And then we'll say IP OSPF 1 area 0. And then interface loopback 101. IP address 10.1.2.1, 255, 255.0, IP OSPF 1 area 0, and then interface loopback 102, IP address 10.1.3.1. We'll make these all /24s. IP OSPF, OSPF 1 area 0. So do show IP interface brief. So there we go, 10.1.1.1, 10.1.2.1, 10.1.3.1, and if I were to say do show IP OSPF interface brief, you can see that those loopbacks now have that they are running, OSPF processes running on these loopback interfaces right here, right? So now let's go ahead and let's do a summary at the ABR for area 0. So area 0 range, and it would be 10.1.0.0, and real quickly here, whoops, that is not what I wanted to do. And I don't know why it did that. See if we can make it larger here without losing everything. Yeah, so, yeah, that actually shrunk. I guess I hit the, there we go. All right, so we'll leave the procedure to the side because we're kind of done with the procedure. So again, on router 1 here, I'm going to put that area range command in, and what I wanted to do was figure out, you've got the 1, so we've got 10.1.1.2 and .3, so we've got 1, 2, 3, 1, and then 2, and then 3. So it's going to stop right there. So we're looking at a slash 1, 2, 3, 4, 5, 6, so slash 22. Is that right? Yeah, slash 22, so 10.1.0.0 slash 22. So let's go ahead and clear the screen here. And let's drop in our area range command. So area 0 range, and we're going to summarize this as a 10.1.0.0, and it's going to be a slash 22. Did I say 22? So 252. Is that right? Yeah, 252.0. Right? So I'll hit enter here. So now let's say do show IP interface brief, or I'm sorry, do show IP route OSPF. And do we have a slash 22? We do. You can see right up here. Here is my summary, right, that I have. I've got a slash 22 right here. I'm doing summarization in area 0 on the ABR. Let's pull the diagram back up. Let's come over to router 2, and let's see what router 2 sees. Do show IP route OSPF. Do you see a slash 22 on router 2 for the 10 dot space? There's a slash 21, but that's for the one that we configured already. So where is it? It's not here. And so this is what I was talking about. So again, summarization from area 0 out across a virtual link is not going to work, right? So if I come back up here, you can see, remember, we did this little virtual link here, right? We put a virtual link for area 100, and we summarize this way, and that works great. However, I created a whole bunch of loopbacks here and wanted to summarize here. Did it go out that way? And the answer is no. So that leads to the question, did it go this way? Well, let's check. Let's jump on to router 3, and let's type in show IP route OSPF. And did we pick up the slash 22 for the 10.1.0.0? We did. And so this is what I was talking about when I said, one of the limitations or one of the drawbacks of virtual links, it's not just troubleshooting. Troubleshooting is definitely more difficult when you're dealing with virtual links. However, this is a major and significant drawback if you're doing summarization. Let's say you've got, 10 to 15, or let's get that out here. Let's say you have 10 to 15 routes that you're trying to summarize out of area 0 into area 1 and area 2. And then you make this design flaw here where you say, oh, well, let's go ahead and put area 51 here because area 51 is a cool number. So let's do that. And then all we need to do is a virtual link. What did you just do? You just killed that area 0 range summarization statement is now no longer going to flood that summary over here to router 2. However, it keeps working to router 3, right? Because, again, we don't have a virtual link here. And so that's where it breaks the summary. And again, why does it break the summary? It breaks the summary because we have extended area 0 all the way over to router 2, right? So it's not going to send a summary into this direction across the virtual link because it believes that the virtual link is extending area 0 to router 2. So it doesn't get sent that way, but it does get sent this way because there is no virtual link over on this side. Okay, well that wraps up the OSPF route summarization. Again, another fantastic activity to really drive home the core concepts of where you can do the summarization, where you can't. And we actually took a little extra look there at a virtual link, how we set the virtual link up, and we saw that, hey, it's okay, we can summarize coming this way across that virtual link because, again, we're doing it on an ABR here, whereas when we're doing it here, this guy is not seen as the ABR when we extend area 0, right? So that's why he's not flooding that summary this way. It's going across the virtual link, so it thinks it is area 0. Okay? All right, well, fantastic. I thank you for watching, and we'll see you on Monday.